Hello and welcome to this is number 2 of Level 1/2 Cambridge National Award Certificate in Systems Control Engineering R113 Electronic Principles. Now we still haven't looked at the exam paper yet, but if you remember from the previous video we were looking at some of the basic concepts of electricity and electronics. Specifically we were looking at direct current, and we were looking at basically how a voltage source, in this case we were using a battery, and how basically electricity was in electrons moving through a wire, a positive charge moving in the opposite direction, so it makes it look like there's a flow of electricity, and we describe this flow of electrons as being a current, which is measured in amps, and we discussed how the electrons moving through a material experience resistance and therefore give up energy, in this case as a bulb, and create heat and light. And we discussed this concept of resistance and Ohm's law, which we're going to be looking at in a little bit more detail. And we talked about how the battery acted as a pump, pushing the electrons around the circuit with a certain amount of pressure, if you will, and how we describe this as using the term volts. We looked at Ohm's law, which is basically a relationship between the voltage, the current and the resistance that always remains the same, in such a way that if you had, in our example we have 50 ohms of the circuit here in the circuit, and therefore knowing that we've got two cells of 3 volts each, what current would be required for the electrons to pass through that resistor of 50 ohms with the pressure of 3 volts. And I left you to answer that question, and we'll see if you got the answer right. So let's have a look at a quick reminder. It's good if you get into the habit of when you're working with electronics to record your formula, and get into practice is putting it down somewhere, so that, especially Ohm's law, this can be the first one that you're probably going to encounter in the examination that you're going to need. So we cover the I is equal to, the volts was 3 volts, and we had a resistance of 50 ohms. So the current would be, okay, let's just have a look. So 3 volts divided by a resistance of 50 ohms means that the current required, or the current generated, would be 0.06 amps. Now that might seem like a really low number, but that's actually not very surprising for a sort of a low voltage circuit. 1 amp is an awful lot of electrons. As a shock you would feel uncomfortable. So 0.06 amps might seem small. It's a typical number for the sorts of circuits that we're going to be looking at. Very low amperages. So what does this actually mean then? Well, we're going to need to talk about resistors and sort of what electron flow is. Basically, I'm going to sketch a little sort of an X-ray version of a resistor here. So the electrons come in and sort of mimic the shape of a resistor as well. Basically, the electrons are travelling down a wire, usually copper. Metals have lots of free electrons, remembering that sort of when your circuit's switched on, every single electron starts to move. It's not just a case of 1 or 2 electrons flowing through the circuit, it's literally a line of them. Everybody shifts one place to the right, and then everybody shifts one place to the right, and it's sort of, that happens at the speed of light, if you will. Well, part of that is that when you encounter a resistor, not resistance, because resistance exists in all sorts of different components. We're going to just specifically look at the resistor as a starting point. Why is it resistant? What are the electrons having to do? Resistors are semiconductors. They usually contain silicon or sand and metal particles to allow the current to flow, but effectively, unlike the copper that has free electrons, and therefore there's plenty of electrons to shift across, travelling through here where you've got your sort of fixed ions, if you will, not all of which are conductive, it's a semiconductor, so it's going to be full of silicon, semiconductor, semi like meaning half conductor, half insulator. The electrons sort of have to travel. They have to sort of travel a slightly more random path to get through, and of course the more dense this area, or the more sort of resistance, if you will, they encounter, then the slower, the more difficult it is going to be for them to travel through. And in doing so, they're going to give up energy. So often the energy sort of being radiated will be heat. And you find that a lot in electronic circuits. One of the biggest problems with electronic circuits is, as you know, pops with the computer, there's always a fan running somewhere to take away this excess heat, the energy from the process. So resistor, basically electrons coming in, encountering resistance through this concept of semiconductors, that are sort of half conducting the material and half resisting it, and of course the amount of conductivity against the amount of sort of insulation gives you a factor of resistance. And we use a resistor of 50 ohms, which is quite a low resistance, and quite typically we sometimes deal with values of 1000 ohms, which we refer to as 1K, and it's common to see 2K, 5K, even 100K or more, depending on the need of the circuit. And what we're going to do is we're going to have a look at an example of how you would select a particular resistor for a given situation, as an example of how to apply Ohm's law, but also how to make a decision in a circuit, and also answering a typical exam question. So if we have a look at the sample paper and we look at this, we have a question, and I'm going to use this part of this question. The answers are already given here, if you will. We've got a potential of 6 volts in total coming from some sort of power source. You don't need to worry about that. And that 6 volts is passing through the resistor and the LED, and it tells us here that it's 330 ohms of resistance, and then we've got our LED giving out light, and the potential is 6 volts down to 0 volts. It's a sort of terminology that we use when we're talking about circuit. The potential, the voltage drop across a circuit or a set of components within a circuit. So that's the sort of, again, you'll recognise this. This is what's called a limiting resistor. LEDs are very delicate and they always require a limiting resistor. So we're going to look at that scenario as part of sort of what you might encounter in an exam. So we're going to label this as an exam question. Okay, and we're talking about some voltage going through some form of resistor, passing through an LED. The symbol here is for a diode. The circle sort of indicated that it's got a lens, and obviously this indicates that light's being emitted. This is just the symbol for a resistor. It's just a rectangle. Sometimes you might occasionally see this in diagrams. That's the American version. And then refer to this as the positive rail, and this one as the negative rail. So here I've got an LED. Now typically an LED would operate about 0.02 amps, and it would require about 2 volts. Okay, so imagine we've got a sort of a typical square 9-volt battery. They're always good examples. So now 9 volts is a lot compared to what we actually need is 2 volts. Remember that we're going from 9 volts down to 0 volts. So in this space here, we've got 2 volts here. So for this resistor here, this resistor needs to use, if you will, the remaining voltage. The remaining voltage needs to be accounted for. So the total across the circuit is 9 volts. But actually the voltage across each component can be different, and in fact it needs to be different. The LED can't withstand too much current or too much voltage flowing through it, because they will actually, they'll pop, they'll literally explode. So if the LED is operating at 0.02 amps and it's using 2 volts, then we know that we've got 7 volts here, and we know that that 7 volts is operating at, for this circuit, 0.02 amps, then that resistor must have a value to keep that 7 volts at 0.02 amps. So if we apply our Ohm's law to calculate resistance, we've got V divided by I. Well, there's V. Divide that by the current. It's going to give us so 7 volts divided by 0.02 amps will equal 350. So we need a resistor of 350 ohms. So 350R is another way of writing it, so that it will limit the resistance going into, or limit the current going into the LED. So it's a limiting resistor. We calculated the value by using Ohm's law. So here's another one for you to take away. I've got a 6-volt battery. I've got a resistor, and I have here, this is a blue LED. Now, blue LEDs of red and green LEDs were quite easy to produce, but blue LEDs, because they're white light and required higher energy levels, was much more difficult. And needing much higher energy levels, we're going to give you the challenge of 0.03 amps. Okay, but this is going to use, I want you to imagine this is one of those blue LEDs that's maybe perhaps lighting up a moped or a motorcycle working on a 6-volt direct current. So what resistor do you think I would need? And when we come back to the next video, you can see if you've got the answer right.